What's going on, everyone? This is Gaurav and welcome to my learning channel. In today's video, we'll learn about Bayes' theorem. We'll get started with what is Bayes' theorem, the mathematical formula behind it, and then followed by one simple example. You could potentially expect an example like this in the interview setting, or probably something which is a little bit more complicated. So without any further delay, let's get started. Now, before we dive into the details of Bayes' theorem and the mathematical formula behind it, just a 5-second history lesson. The Bayes' theorem was originally developed by Thomas Bayes in sometime in 1700. That's about it. That's all of the history lesson I have for you. So now let's take a look at the Bayes' theorem, the formula behind it. Now, before I dive into the details of this formula, I'm assuming that you have a good understanding of conditional probability. And if not, then I would request you to pause this video for a minute, go back to my playlist on probability and take a look at the conditional probability and then come back. Now, if you already know what is conditional probability, let's dive into the detail of this scary looking formula. As per Bayes' theorem, for the events A and B, probability of A given B is equal to probability of B given A multiplied by probability of A divided by probability of B. Quite a mouthful. So let's try to demystify it and break it down into smaller chunks. Now, while learning the conditional probability, we saw that the formula for conditional probability is probability of A given B is equal to probability of A intersection B divided by probability of B. If I simply go ahead and flip A with B, then it will be probability of B given A is equal to probability of B intersection A divided by probability of A. Now let's focus probability of A intersection B and probability of B intersection A. And let's try to understand this with the help of a simple Venn diagram. So in this Venn diagram, the rectangle represents your entire event space. You have two events, A and B, and the intersection is this shaded area. So probability of A intersection B will be this shaded area for this entire event space, and probability of B intersection A is again going to be the same shaded area for this entire event space. Now, as you can see, that probability of A intersection B and probability of B intersection A are sort of talking about the exact same shaded area, and that's why they're exactly the same. So if I simply go ahead and plug this back into this formula, so probability of A intersection B and probability of B intersection A are exactly the same, and I simply rearrange the items, then the formula will look something like probability of A given B is equal to probability of B given A multiplied by probability of A divided by probability of B, which is exactly the same as we saw in the last slide. So now I hope you understand where is Bayes' formula coming from and what is the overall mathematics behind it. Now the next question is, when do we use Bayes' formula and what are some of the typical examples? So oftentimes you might actually run into a situation where probability of A given B is supposed to be calculated, but it is very difficult to calculate given all of the information. However, typically in an interview settings, you will see that right-hand side in some way, shape and form will be provided. So you will have all of these three different items, or you'll be required to calculate it and put it back into this formula so that you can arrive at probability of A given B. So let's take a look at an example to better understand this. So let's take a look at a very simplistic example, and this is the type of question that you could potentially expect in an interview setting. So the question is, we all know that smoking causes some sort of a lungs disease. Now, what is the probability that a person will have a lungs disease given they are a regular smoker? Now let's assume that being a regular smoker is something which is very well defined. This could be things like anyone who smokes more than, let's say, 10 cigarettes a day. Now, on top of this, I give you 3 more data points. So the first data point is, of the people who are regular smokers, 30% had lungs disease, and probability a person will have lungs disease is equal to 2%. And the third data point is, probability a person is a regular smoker is equal to 3%. Now, based off of these 3 additional data points, let's try to calculate what is the probability that a person will have a lungs disease given they are a regular smoker. Now, given we already know this formula, so let's try to break this down, the given information as a part of A and B. So let's say event A is probability a person will have a lungs disease, which we already know is 2%. Event B is probability a person is a regular smoker, so that is 3%. Of the people who are regular smoker, 30% had a lungs disease, so that is equal to probability of B given A. Now, if I just simply go ahead and put all of these 3 different data points as a part of this formula, then probability of A given B will be equal to 20%, which is what we are looking. Now, typically in an interview, before arriving at this particular formula, there is a possibility that you will have to do a few more calculations. So there's probably going to be additional nuances either to calculate probability of A or probability of B or probability of B given A. But the core essence sort of remains exactly the same. So hopefully this gives you a good idea about what is Bayes' theorem, what is the associated formula, and what are some of the typical examples you could potentially expect in the interview setting. If you like a content like this and would like to see similar videos in the future, I would request you to please like and subscribe my channel. This is definitely going to help me and the channel a lot. I wish you best of luck in your learning journey. Thank you.